Hi everyone! In this video, we are going to explore on how to create a perfect playlist within a set of time limit to maximize endorphin levels. Using a smart selection process inspired by 01 knapsack problem will determine the best combination of songs that fit within your available time while giving you the highest emotional boost. Stay tuned as we dive into the science of music, mood, and optimization.
Let's now break down the code that helps us pick the best songs based on their endorphin boosting potential. Now, we have 10 songs, each with a fixed duration of 500 seconds. Each song provides a different level of endorphin boost. Our goal is to select songs that gives us the highest level of endorphin level, while keeping the total listening time within 5,000 seconds. The first line in our code is import numpy as AP. This allows an efficient management on our data using arrays and matrices. The second line has all the examples of our songs, and the third line represents each song that has the same durations of 500 seconds. So we use Python's list multiplication to create a list of identical values. And in this line, each song also has a different level of endorphin boost, which we store in this list. And in this line, S is equals to 5,000, maximum allowable listening duration. It means that the total available listening time is limited until only to 5,000 seconds. And in this line, n equals length song durations. The variable n stores the number of songs in our list. Now we have created a 2D matrix dynamic program table filled with zeros, where rows represent songs and columns represents different time constraints. We now iterate through each song and through all possible time constraints to find the optimal combination. If the current song duration fits within the remaining time, we decided whether to include it. Now in this line, we use the knapsack formula to choose the better option. Either we include the song and gain its endorphin boost, or we exclude it and keep it with the previous best value. And in this line, if the song doesn't fit, we carry forward the previous best results without adding it. Once our program runs, it outputs the song matrix, showing how much endorphin boost we can achieve in a different time intervals. We format our output, creating a header row with the time intervals of 500 seconds. Then we iterate through the results and display the optimal endorphin values for each song that has a different constraint. Now let's analyze the output of our program, the song matrix. Display how much total endorphin boost we can achieve by selecting different combinations of songs within various time limits. Each row represents a song, while each column corresponds to a time limit, 500s, 1000s, and 1500s, and etc. Each values inside the matrix indicate the maximum endorphin level that can be obtained at a specific time limit when considering the song up to the row. For example, if we look at the last row, the column 5000s, we can see the maximum endorphin value achievable within the full time limit. This represents our optimized playlist selection. So our optimized playlist selection is The Boy with Love. By examining how these values change across rows and columns, we can see how adding or removing certain songs affect the total mood boosting potential of our playlist.
In this part, the matrix was used as a reference for solving the endorphin levels. The goals of this is to have a list of songs which can fulfill the time duration of 5,000 seconds this started for having the total time duration of the given 10 songs, or uh, based on the given, the time durations are uh, totaled, then came up with 3,250 seconds. Then also the endorphin levels was totaled, and it sum up into having 2,450 endorphin levels. Um, so the remaining seconds for having 5,000 seconds minus 3,250 seconds rather is equals to 1,750 seconds. Then that remaining seconds uh will be having the random, or will be filled with seconds that has higher endorphin levels. Then for it to be more easier for us to compute, we rank the endorphin levels from the highest to lowest, corresponding with their corresponding time durations or seconds. Then, since we are going to compute the remaining time, or we can say that we are going to use the total list of our 10 songs, since it is stated there that um, uh, there must not be repeated songs unless the whole 10 song was played. The remaining 1,750 seconds will be filled with songs with higher endorphins. Since we already ranked them, it is much easier. Uh, then the 1,750 seconds will be having rank 10 endorphin level, total of endorphin levels, from highest to lowest. Total endorphin level appeared in the matrix, which has, yun nga, 2,450 seconds. Kumbaga, ginawa nating standard yung total nung time duration and nung uh, endorphin level for us to parang ma-narrow down yung dapat natin gawin, na ang gagawin na lang natin is i-fill yung 1,750 remaining seconds para mabuo yung 5,000 seconds. After that, when we already have the 10 list of song combinations, lahat na nag-total talaga sa 5,000 seconds, irarank natin siya from highest to lowest. We will distinguish which combination has the best song list for having the highest endorphin level.
So today, I'll be presenting a Python function that models a song selection process where songs are played in cycle until a given maximum duration is reached. The goal of this function is to maximize the total endorphins released during the listening session. The song selection process takes into account both the duration of each song and associated endorphins level. Let me walk you through this implementation. So the function cycle-based selection takes three inputs: song duration, endorphin level, and max duration. So first, we do is calculate the total time for one full cycle of songs and total endorphins generated in that cycle. A cycle refers to the playing of all songs once in a sequence. Next, we calculate how many full cycle of songs can fit into the given max duration. We do this by performing integer division of max duration by the total song time. After determining how many full cycle can fit, we build the sequence selected song. The least selected song starts by repeating the song full song list for each cycle. Once the full cycle are accounted for, we check the remaining time. We sequentially add songs until the remaining time is less than the duration of the next song. Now, we calculate the total endorphins released during the full cycle and the partial cycle, if any. This is done by adding the endorphin level for the selected song. And finally, the function returns to value. Total endorphins. The total endorphins value achieved within the max duration and selected song. The sequence of songs played. To test this function, we define some example song duration and endorphin levels. We also test this function with different maximum duration to check. Here's the code to compute the result for this function. And finally, you print the result for each max duration, displaying the total endorphins and selected song sequence for each case. So in conclusion, this function is helpful in scenarios where you want to maximize a certain objective, in this case the total endorphins. While respecting a time constraint, the approach efficiently calculates the optimal song sequence within the given duration, considering both the total time and the reward associated with each song.